Good morning, my dear friends. I hope you all are doing great. So, dear friends, let us start our topic for today. So, I have come up with a question. This question will give you the essence that how does, the questions are being asked in the competitive exams. So, let's have a look. My dear friends, I have compounds here with me. We have compound P, Q, R and S, my dear friends. So, we have 4 compounds with us. Their lattice enthalpy is also given, and you know that lattice enthalpy we have here positive values. So understand that it is the lattice enthalpy of dissociation, my dear friends. So this is a lattice enthalpy here, but you should know that it is related to the dissociation, my dear friends. Okay. Now these are the values with us of lattice enthalpy. Now look at the hydration enthalpy values for 4 compounds. These are the hydration enthalpy values for 4 compounds. And this is exothermic, my dear friends. Okay. So what I am going to do, I want to tell you. We have done in theory one expression, if you remember. That expression was delta H solution. Yes. Is equal to delta H lattice plus delta H hydration, my dear friends. So that was our expression, my dear friends. Now how come you will make out that whether these particular substances, if you look P, Q, R and S, the pair of compounds which is soluble in water. So out of these 4 compounds, which pair is soluble in water, my dear friends? On what basis you will do this particular question? You have read lattice enthalpy, you have read hydration enthalpy, you have read enthalpy of solution, you have read everything. But see how the question will appear in the competitive exams. Have a look. You have to tell that which pair among them is soluble in water. And for this, you have to remember a very small thing, my dear friends. You know what is that? Look at it. If you remember this much small thing, delta H hydration. Yes, when delta H hydration value is greater than delta H, okay, lattice. Remember this expression, my dear friends. Standard enthalpy of hydration. Yes? So I will write down here. When standard enthalpy of hydration value is greater than standard enthalpy of lattice, then what happens? Then compound is soluble in water. Okay? At room temperature. So my dear friends, now you have understood that what is actually the trick for this particular thing. That standard hydration enthalpy should be greater than standard lattice enthalpy. And remember, this is the lattice enthalpy of dissociation. Please remember that. Okay? So my dear friends, let's have a look now here. I have a compound P with me. Yes? How much energy is required to break it? We require 780 kilojoules of energy to break P. Okay? How much energy is released during hydration? Yes? That is 920 kilojoules are released during hydration of compound P. Now that is a very simple thing now, my dear friends. This energy which is released, this hydration enthalpy, you can also call it as available energy, my dear friends. Please remember this thing, available energy. Because when energy is released, let's suppose 920 kilojoules of energy is released during which process? Hydration of which compound? P. I can store this energy. Let me store that energy. Compound P on hydration is releasing this much of energy. So we can store it. Just imagine, let us store this energy. How much of energy you are storing? 920 kilojoules because it's released by P on hydration. So you have stored it. So how much of energy you have now in storage? 920 kilojoules of energy you have in storage. Yes? And how much of energy is required to break the compound P? How much energy is required? 780. How much is available with you? 920. So I can call it as also dissociation. We know it's a required energy. So available energy is 920 and required is only 780. That means I can easily, okay, dissolve the compound P in water, my dear friends. So it is soluble because our available energy is 920 and required is only 780. So I will take 780 out of it and will dissolve P in the water. So that means P will be soluble, my dear friends, in water because the hydration enthalpy value is greater than lattice enthalpy. Don't look at sign minus and plus. Minus will represent energy is lost, which we can store. So it will become available energy. And here energy is required, means endothermic. So don't look at plus minus sign, look at the value, the quantity. So here 920 and 780. So look here at this point. Hydration, standard hydration enthalpy is greater than lattice enthalpy, my dear friends. So this compound is soluble in water. So P will be soluble in water. So in first case, my dear friends, I will write down here delta H hydration, okay, is greater than delta H lattice. So that is our expression. So obviously we will write down it is soluble. So this guy is soluble. Now look at the Q. In case of Q, lattice enthalpy is more, but the hydration is less. Available energy is 812 and required is 1012 to break the compound Q. So here the expression is reversible, like delta H hydration is less than delta H naught lattice. So this guy is obviously insoluble. Now look here at R. Let me move faster here. Released energy means available energy is 878. That means here hydration is greater than lattice. So obviously this guy is also soluble. And finally you have S. Released energy means available energy is 600 and required energy to break the compound S is more. That means hydration enthalpy is less than lattice enthalpy. So obviously this guy is insoluble, my dear friends. So I hope for competitive exams you can easily do this particular thing. Now this is the application. Whatever you are reading in theory, okay, little twist will be there in the competitive exams. When you are facing NEET exam or JEE exam, they are giving a little twist. So you need to know this little relationship beyond your book. Are you following my point or not? So obviously now you can easily tell me that which two compounds or which pair of compound is soluble in water. P is soluble and R is soluble. So obviously my answer will be P and R. The D option is the answer, which are soluble in water. I hope, my dear friends, you have understood this question. Okay, whatever you are reading in the theory, you need to apply that to do the questions, for competitive exams. So that is very much important. Understanding a concept is important, first thing. Second thing is that how to apply that concept and what are the extra things you have to learn to crack the questions. Are you following or not? That is important, my dear friends. So please make note of this. I hope you understand. Dear friends, let's talk about now spontaneous process and spontaneity. These are the two terms, my dear friends. First of all, we'll look at the spontaneous process. So what is a spontaneous process usually, my dear friends? Most of the times, the students will be confused when they think of a spontaneous process. When you read a statement from your NCERT book, this is the statement of your NCERT book, that is, a spontaneous process takes place by itself without the help of any external agency. Means you don't require any help from the external source. Is it true? It's not true, my dear friends. Even the spontaneous process also requires very little help. Yes, we can also call it as a differential help. Yes, and then only it will take place, my dear friends. But when the help is very small from outside, then understand that help is neglected. We are thinking that there is no help, but help is there. But how much of help? Is a very small help from outside, and that is called as a differential help. But if you look at the statement here, a process which takes place by itself without the help of, this statement is important. This point and this point is important. Without help of an external agency. In this statement, you will be thinking, oh, no help is required for spontaneous process from outside. But let me tell you, my dear friends, help is required. But that help is very small, called as differential help is required, my dear friends. So for you people, I will write down a little statement here. I will write down differential help. We also call it as ignition or rekindling. Rekindling is not required. So differential help or ignition is required for spontaneous process. And when we call it as a differential help is required, this differential help is very small help. It's a very small help. So obviously it will be considered to be negligible. So when this differential help is negligible, that's why we are telling without the help of an external agency. We are telling that no help is required. But remember, my dear friends, differential help is required. But very small help is required. Let us take an example, my dear friends. At our homes, we have LPG gas. Okay? That is liquefied petroleum gas we have. Liquefied petroleum gas. It contains butane, isobutane and all, but let me take butane here, okay? So this LPG gas is nothing but, it is our butane. Okay? So one component is butane in it. Okay? So what is this butane all about? It is C4H10. C4H10 is butane, my dear friends. Now, in our homes, my dear friends, we want to burn the LPG gas, correct? Do you think you will just on the gas and LPG gas will burn by itself? No, it will not burn by itself. You are using the lighter. You are giving a little spark. That little spark is nothing but, that is your what? We can also call it as spark, and that spark is nothing but it's an ignition, my dear friends. And that ignition is nothing but it's a differential help. Very small help. You are, when you on the gas, the LPG gas, butane comes out, my dear friends. Do you think you will be watching the gas? Gas is not visible at all, but you will be watching whether it will burn or not. It will not burn, my dear friends. So, but what is the statement here? Without the help of an external agency. This statement actually means, my dear friends, that you require the help, but that help should be very small, and that will be the negligible help, my dear friends. So let us go on here. This is our butane. So in presence of oxygen, my dear friends, this butane will burn. Okay? When this butane burns, it will give me carbon dioxide and water. Carbon will burn to give me carbon dioxide. Okay? Hydrogen will burn to give me water, my dear friends. How many carbon atoms are here? 4, my dear friends. So we will take it 4 times. Okay? Now finally, my dear friends, how many hydrogens are here if you look? We have 10 hydrogens here, my dear friends. So let us take it 5 times here. 5 2s are 10. So 10 hydrogens and 4 carbons we have here. Let us see the oxygen here. 4 into 2, 8 and then 5. 8 and 5 will be how much, my dear friends? So here you have 8 oxygen and here you have 5 oxygen. It will be 13. So 13 oxygen you have here, my dear friends. So what to write down here for oxygen? So I will write down here O2. Can I write down 6.5? 6.5 into 2 is how much, my dear friends? 13 oxygen. So obviously we have balance in the reaction, but balancing was not required here. Okay? So you are providing a spark. Okay? A spark is provided. Okay? By lighter to burn butane. But how much of spark is this? You know, my dear friends, this spark is basically a differential help. This spark is a differential help and it's almost negligible, my dear friends. So we will tell that no help is required because help is differential only. So you will burn this butane, you will be getting carbon dioxide and water, my dear friends. Apart from that, lots of energy will be released, my dear friends. You will be getting energy as well. Okay? So, my dear friends, in this process, energy is released also. So we call it as, this is the burning of LPG. It's a spontaneous process, my dear friends, or spontaneous reaction. Because large amount of energy is released. Yes, you can mention this energy also here, that delta H for this process, it's a combustion process, is negative. Negative means energy is released. Energy is released. Okay? Now look here, my dear friends, how much of energy you are giving for burning the butane? Less energy, but how much of energy is released? This negative value is large. So large energy is released, my dear friends. So it's a spontaneous reaction. But it requires a little help, that differential help is required. And that is almost negligible, my dear friends. Let us take one more example here after this. Let us suppose there is a mountain. Okay? So we have a mountain here. Okay? This is the top of the mountain and this is the foothill of the mountain. And let us suppose there is a rock at this point. There is a rock. Correct? So this is the top of the mountain and there is a rock. Correct? This rock has the high potential energy. Here the potential of the rock is very high. Okay? And now this is the foothill. At foothill the potential is very less at the base of the mountain. Foothill means base of the mountain. Okay? So here we have a high potential and here is a low potential. So at this point I will mention that potential energy is high for the rock. Okay? So what will happen? It has to come down. Yes? When you just push it, my dear friends, it's a spontaneous process, my dear friends. This rock will come down. We know that it's a spontaneous process. Yes? It will come from the top to the foothill. But remember one thing. If it is a spontaneous process, yes, but it also requires some energy, my dear friends. Look here. A person will be here. Okay? This person has to push it, my dear friends. Okay? So I will tell here. This person has to be on the mountain, not in air. Okay. So, little push is required for this process. And that little push that little force is negligible. Because when you give a little energy to something, that little energy is not counted, my dear friends. So that is almost negligible. Okay? So, but that's why we tell without the help of an external agency. I hope you are understanding, my dear friends. Energy is required, but how much? Very, very little energy is required. When you push it, when this person pushes the rock, it will roll down. Yes? So I will write down rolling down of rock from top of the mountain, from top to the foothill. Okay? Is a spontaneous process. Is a spontaneous process. So my dear friends, this is also a spontaneous process, even though little amount of energy is required, and that little energy, that little push will be considered to be negligible. So this will become the definition. I hope you are understanding my points or not. Okay, let me give a few more examples here. Let us talk about now osmosis. If there is a process called as osmosis. What is osmosis? Okay, it's the flow of water from higher concentration to from its higher concentration to its lower concentration through a semi-permeable membrane. Now you will be thinking that what is this semi-permeable membrane? The semi-permeable membrane means that particular selectively permeable membrane which will only allow the water to pass. It will not allow the other substances to pass through it. So my dear friends, the flow of water from its higher concentration to its lower concentration through a semi-permeable membrane. Once again, what is semi-permeable membrane? That selectively permeable membrane which will allow the water to pass through it. Remember that. So this is also a spontaneous process. This is also a spontaneous process, my dear friends. Correct? Now, one more thing we'll talk about here. That is flow of heat. Flow of heat from hotter object to colder object is a spontaneous process, my dear friends. So it is a spontaneous process, right? So I hope you have understood what is spontaneous process all about. A process which takes place by itself without the help of an external agency. You can tell like this. Or you can also tell like this. A process which takes place by the help of differential amount of energy. That means by the help of negligible amount of energy, or by the small ignition, or by the small rekindling, or by the small push. So my dear friends, you have understood now the meaning of spontaneous process. Let's take one more example here, my dear friends. That is quite common. Dispersion of ink in water. There are so many examples, but let us restrict ourselves to few examples only. If you take ink, okay, and put it in water, then you observe the water. You'll find out that that ink will be dispersing in the water, mixing with the water, and you can see that. And that dispersion of ink in the water is also a spontaneous process, my dear friends. Now, there's a question now. Whether you can reverse the spontaneous process or not. Yes? Remember, spontaneous process is irreversible. But you can reverse it also. How? But you have to spend lots of energy. By the help of external agency, spontaneous process can be reversed, my dear friends. Let me teach you that particular point. Please make note of this. Remember this important point now, my dear friends. spontaneous process is irreversible and can be reversed by the help of external agency. Now you will be thinking, what is this external agency? This external agency can be that slight push. Yes, it can be temperature, it can be heat, it can be pressure, it can be anything, or it can be any kind of a force, my dear friends. Now I told you that spontaneous process is irreversible, my dear friends. Let's take an example here. Now what we were doing, this was the top of the mountain and there was a rock at here. Okay, it was at the edge. Okay, so a slight push is required. So we are applying a little force onto this. Okay, so little force is required to push the rock. Yes. So what happens? This thing will come down. It will roll down here, and it will reach to the foothill. That is the base of mountain. Base of mountain. So my dear friends, this rock has come down in this direction by the application of little force, little push. Okay. So my dear friends, this is a spontaneous one. This is a spontaneous process. And I told you that spontaneous process is irreversible. You cannot reverse it. But if you want to reverse it, then can be reversed. It's also written here. By the help of external agency. If you want to reverse it, you need the help of external agency. Let's have a look. So this was spontaneous process. Let's take again rock here. Okay. You are applying some force onto this. Okay. A force is being applied onto this particular thing. So when you apply the force, this rock is present at the foothill, at the base of the mountain. So you are making this rock to come up to the top. Do you think this requires less force or more energy is required, my dear friends? So more energy is required to take this rock back up to the top. So my dear friends, spontaneous process was actually rolling of rock from top to the base or to the foothill. That is spontaneous. Yes. Here what happens? Little push is required. Little push is required. But in this particular case, if you want to take this rock up to the top, my dear friends, what happens? Here, large amount of energy is required. Amount of energy is required to push the rock back to the top. Yes or no? So this is the reverse direction. So more amount of energy is required here. So you can reverse it. Yes? This was a spontaneous process from top to bottom. So rock was being made to roll down from top to bottom or top to foothill. That was spontaneous. Less energy was required. But if you want rock to come up back to the top, you have to spend lots and lots of energy you have to give. That means you can reverse the spontaneous process, but you have to spend lots of energy. And that lots of energy is your what? External agency, my dear friends. That force which you are applying, that's your external agency. So, my dear friends, remember always one thing. Spontaneous process is irreversible. Why we tell like this? Because we know that if we reverse the spontaneous process, lots of energy is required. Please remember that particular point. Large amount of energy is required to reverse a spontaneous process, my dear friends. Okay? If I gave you just one more example here, my dear friends, you will understand it better. Now look here, my dear friends. Let's take an example. Let us suppose I have Na plus, okay, gaseous and Cl minus gaseous, and I am getting 1 mole of NaCl, which is solid. For this reaction, I have already told you that here delta H will be basically delta H naught. It's the lattice enthalpy of formation of whom? NaCl. It's equal to minus 788 kilojoules per mole. Yes? And remember, this is a spontaneous process, my dear friends. Because here energy is released. So it's a spontaneous reaction. If I take the reverse of this, what is the reverse of this, my dear friends? NaCl solid, I'll break it into Na plus gaseous plus Cl minus gaseous. So here we have delta H lattice. That is the dissociation of NaCl, my dear friends. It will be exactly endothermic, that is plus 788 kilojoules per mole. So my dear friends, this is the reverse of the formation. What is that? Dissociation. That means formation is a spontaneous reaction, but this dissociation requires lots of energy. So it will be a non-spontaneous reaction. Because non-spontaneous reaction requires lots of energy, my dear friends. Remember, if forward reaction is spontaneous, the backward reaction will be non-spontaneous. Yes, my dear friends. So remember that. If forward reaction is spontaneous, then backward will be non-spontaneous. So this is just a general statement. It's not necessary that it will be always true, but in general this is the only case actually. So if I talk about now lattice enthalpy of formation and lattice enthalpy of dissociation, obviously the formation is a spontaneous process and dissociation is a non-spontaneous process. And non-spontaneous process will require lots and lots of energy. And remember that particular thing. And one more important point I would like to mention here, that is spontaneity. What is spontaneity? We have learned the spontaneous process. Spontaneity means basically the potential of the power of a particular, physical process or chemical reaction to take place without the help of external agency. So we call that potential or power of that physical process or chemical process as spontaneity. That water has a power to flow from higher concentration to lower concentration, and that power of the water to flow without the help of any external agency is known as spontaneity. The heat has a power to flow from the hotter object to the colder object, and that power of the heat will be called as the spontaneity. I hope, my dear friends, you have understood that particular thing. Please make note of this. So dear friends, let us talk about now non-spontaneous process. Obviously spontaneous process takes place without the help of an external agency, and you have also remembered that help is basically differential help, and we are neglecting that and we are telling without the help of external agency. Now look here, non-spontaneous process. What is this? A process. It will be exactly opposite of spontaneous process. A process which requires, large amount of energy. I will write down it in my own words. Large amount of energy to take place. So a process which requires large amount of energy to take place is known as non-spontaneous process. Is said to be non-spontaneous process. Let us try to understand now, my dear friends. Okay, have a look here. Look here, if I take on PCl3, okay, I will make the PCl3 gaseous to react with Cl2 gas, and I will be getting PCl5, that is phosphorus pentachloride. and here delta H is basically negative. That's exothermic, and we call this process as spontaneous because here energy is released. So it's a spontaneous reaction. Now let us take the reverse of it. What is the reverse of it? You have to break PCl5, so heat energy is required to break it. Okay? So obviously we will get here PCl3 plus Cl2. And my dear friends, this is basically the, let's call this enthalpy of reaction, that's a common thing. So obviously it is positive. So it's endothermic. And here it is a non-spontaneous process. Because here energy is required. Plus means it will absorb the energy. When you are breaking PCl5 into PCl3 and Cl2, energy is absorbed here. It will absorb the energy, then it will break. That's why a process which requires large amount of energy to take place is said to be non-spontaneous process. For example, if you want to break calcium carbonate, you have to apply the energy. Give the heat energy, large amount of heat energy you have to give, and it will break into calcium oxide and carbon dioxide. And this is also a non-spontaneous process. Or we can say non-spontaneous reaction, my dear friends. Let's talk about one more, okay? If I flow of water from its higher concentration to lower concentration through semi-permeable membrane was spontaneous process. But if I write down flow of water from its lower concentration to higher concentration under the influence of external pressure through semi-permeable membrane. Okay. So my dear friends, the flow of water from its lower concentration to higher concentration under the influence of external pressure. My dear friends, this external pressure what I am talking about here, that is your large amount of energy. So here the energy is basically supplied in the form of pressure. You are exerting the pressure onto the particular water. Okay. So flow of water from its lower concentration to higher concentration under the influence of external pressure through semi-permeable membrane is reverse osmosis. In second PU you will study what is the meaning of reverse osmosis. That's actually used for the purification, yes, of water. Okay, purification of seawater, salt water and all. Okay, that is not my point. My point is very simple here. The flow of water from its lower concentration to higher concentration. And obviously this reverse osmosis is a non-spontaneous process. So it's a non-spontaneous process. Rolling off a rock from the top of the mountain to the foothill of the mountain. What was that? Spontaneous process. Now you are pushing the rock back and taking it to the top of the mountain. What is that? Non-spontaneous process, my dear friends. So obviously, when you are putting ink into the water, so dispersion of ink will take place. Now can you separate ink from the water? That separation of ink from the water, it will be a non-spontaneous process, my dear friends. So please remember that. If the water flows from the third floor to the ground floor, that is a spontaneous process. Okay, through pipe, it comes down from the third floor to the ground floor. Spontaneous process. But if you want water to go from the ground floor to the third floor, what happens? You need electric motor. And that electric motor will provide energy to the water. And then water can go from the ground floor to the top floor or third floor or fourth floor, whatever it may be. So point here is that the spontaneous process is the process which requires differential amount of energy to take place, and that differential amount of energy is almost negligible. That's why we are telling that spontaneous process requires what? No help from the external agency. But remember, it requires, but which help? Differential help. But when we look at the non-spontaneous process, it requires large amount of energy to take place. If you supply a large amount of energy to the rock, then only you can take it from the foothill to the top. That's why if you apply more number of or more large amount of external pressure on the water, then only it can flow from its lower concentration to the higher concentration, my dear friends. I hope you have well understood the concept of spontaneity, spontaneous process and non-spontaneous process, my dear friends. Please make note of this. So dear friends, now we have a kind of a question with us now. Is decrease in enthalpy criterion for spontaneity? Okay, so let us understand. Decrease in enthalpy, what is the meaning of that? Decrease in enthalpy. That is, if you take a standard enthalpy, then it will be delta H R naught, and decrease basically means minus. So here the enthalpy of the reaction, standard enthalpy of reaction is decreasing because energy is being lost. So obviously it's talking about exothermic reaction. So is decrease in enthalpy a criterion? So let's mention here a criterion for spontaneity. Like any chemical reaction where the energy is being released, do you think that chemical reaction is a spontaneous reaction where delta H is negative? So my point here is that this statement I would like to translate it. Okay, I'll write down here most of the chemical reactions, my dear friends. Most of the chemical reactions, okay, having delta H R naught negative, okay, are spontaneous. So now, is decrease in enthalpy a criterion for spontaneity? Means any chemical reactions having delta H value negative will be a spontaneous reaction? Not necessary, my dear friends. My statement was that most of the chemical reactions, but not all. Most of the chemical reactions having delta H R naught negative are spontaneous. So let us take one little example here, my dear friends. If you burn methane actually, okay, in presence of oxygen, so you will be getting here, my dear friends, carbon dioxide and water. Obviously it's a combustion reaction, my dear friends. So what will we expect here? We will expect large amount of energy will be released. So here delta H R naught will be negative. And we know that it's a combustion reaction, we can write down C also. It's a combustion. So this is exothermic. And this is a combustion process. And we know that this is basically a spontaneous reaction. Yes, my dear friends, this is a spontaneous reaction. So you can take other examples as well, where you will find out that whether it's a spontaneous or non-spontaneous. For example, if you take acid and a base, let's suppose I will take HCl, I'll make it to react with NaOH, and I will be getting a salt, and I will be getting water. So acid interacts with the base, and I am getting a salt, and I am getting water, my dear friends. And this reaction also releases, you know what, large amount of energy. So this is also a spontaneous reaction. So here also delta H is negative, delta H is negative. So remember, most of the chemical reactions having delta H are not negative are spontaneous reactions. So in place of this C I can write down R also, does not matter. So what is important here, my dear friends, that is the enthalpy change is negative here. So they are spontaneous. But do you think it's always true? Let's have a look. Look at this process. When you take on NaCl, solid, okay, what you are going to do, my dear friends, you are dissolving it in water. You put it in water, my dear friends. When you put this into water, what we get? We will get Na plus aqueous and Cl minus aqueous. In previous time you have observed that delta HR, yes, enthalpy change of this particular process or reaction, okay, will be how much? 4 kilojoules per mole. Yes. This is not a reaction, that's why I wrote it like this. It's a physical process. So what happens, my dear friends? NaCl will dissolve in water, okay, and I will get Na plus and Cl minus, and we got it as enthalpy of solution. So I am getting Na plus aqueous and Cl minus aqueous here. In this process, it is basically plus 4. So it's an exothermic process. Sorry, it's an endothermic process because positive value is there. So it's endothermic. So when it's endothermic, but it is spontaneous. Spontaneous process, even though it is endothermic. That means when delta H value was negative, the reactions were spontaneous. Now here in this case, the delta H value is positive, but still this reaction is spontaneous. What is the meaning of this reaction to be spontaneous or this process to be spontaneous? It means very simple thing. That means it will take place with the help of little amount of energy. And this little amount of energy which is required here is 4 kilojoules. This will be provided to this particular process even at room temperature. You will be thinking sometimes, sir, it needs 4 kilojoules of energy. My dear friends, we are not providing that 4 kilojoules of energy. This guy, when you dissolve it into water, NaCl is dissolved in water. Yes, that water will provide that 4 kilojoules of energy, or that 4 kilojoules of energy will be provided by the atmosphere. Because we know that room temperature is 25 degrees Celsius. So this NaCl, when you dissolve it in water, it will absorb the heat energy from the surroundings. And how much of energy is available for this to take place? 4 kilojoules only. This much amount of energy is required. So that's why this is a spontaneous process. And even melting of ice is endothermic, because it requires something here. Melting of ice. Melting of ice. Let us suppose you have a water solid and you want to melt it into water liquid. And here also the delta H naught. That is actually the fusion process. Melting is a fusion process. It's also endothermic. But this melting of ice is also a spontaneous process. Now you'll be telling me, sir, how this is a spontaneous process. You take ice, put it on the table, and after some time, at room temperature I'm talking about, after some time, it will be changed into liquid. Who is providing that energy? We are not providing that energy. That energy is absorbing from the atmosphere, because room temperature is 25 degrees Celsius. And the melting of ice requires little amount of energy. It absorbs that energy from the surroundings. Okay? Once it absorbs that energy from the surroundings, it changes into the liquid state. So even though it requires energy, so it is positive. This also requires energy, it's also positive. But still, they are spontaneous. That means, my dear friends, is decrease in enthalpy a criterion for spontaneity? No, my dear friends. But we can tell most of the reactions are spontaneous when delta H naught is negative. But there are some reactions or some process where delta H is positive, but they are still the spontaneous process. So I will tell no, change in or decrease in enthalpy is not the absolute criterion for the spontaneity. So let me mention that particular thing here. So a very simple point I will mention here, my dear friends. So decrease in enthalpy is not an absolute criterion for a reaction or process to be spontaneous. Okay, what is the reason? Reason is simple. Most of the reactions having delta H negative are spontaneous. Okay? But there are some reactions or process where delta H naught is positive, but still they are spontaneous. So we can tell that decrease in enthalpy is not the absolute criterion for the spontaneity of the reaction. Okay? So most of the reactions have delta H negative, okay, are spontaneous. But there are some reactions or process where delta H is positive, but still they are the spontaneous. Because I gave you example of enthalpy, standard enthalpy of dissolution and melting of ice. Okay? And here I give you example of combustion process and acid-base reaction, my dear friends. Yes. So shall I tell you now that delta H naught negative means spontaneous? No. Because sometimes delta H positive is also spontaneous. So remember, delta H naught value cannot decide 100% that the reaction is spontaneous. Yes? I hope everybody has understood, my dear friends. In our next class, we will study about the entropy, and then we will study whether entropy is the criterion for the spontaneity of what? The chemical reaction or physical process. The entropy change, I mean to say. Now look here, there are some more reactions given in your NCERT book regarding this. Is decrease in enthalpy a criterion for spontaneity? You can study them as well. And I have given you some extra examples, my dear friends. Please take care of yourself. Have a great time. Yo-yo.